we're going to be finding the area of segments. So again, let's define what a segment is. The segment is that region between the chord of a circle and its intercepted arc, or its included arc. Okay, so we're talking about this shaded yellow area here. This is called a segment. So we're going to find the area of this. Now, I actually taught you earlier how to find the area of a sector, and that is really important because that's the first step in finding the area of a segment. So visually, here's what's happening. We're taking our segment, subtracting that triangle that we don't want, and then we're left with the segment. So sector minus triangle equals segment. I put the formula down here as well, but if you think about, if you can visualize what's happening, then you don't have to memorize a formula. Let's look at a couple examples. Here's our first example. So I know we need to start with our sector. So area is equal to my sector, so we're talking 1/4 times pi r squared, or 6 squared. I need to subtract this triangle here that I don't want. Now notice it's a right triangle, so that means my radii here are my length, are my base and my height. So I need to subtract 1/2 of my base times my height. So that gives us, we have 1/4 times 36 pi, minus 6 times 6 is 36, half of that is 18. So now 1/4 of 36, that's 9 pi minus 18. And you can actually leave your answer like that. You're also welcome to type it into your calculator. So if I do that, I have 9 pi minus 18 gives us approximately 10.3 square centimeters. All right, here's our next example. Again, we're going to find the area of that segment. We're going to start with the area of the sector. So the area of the sector, we have a 120-degree central angle. So that means that arc is 120 degrees. So that's 1/3 times pi r squared. So pi times 24 squared. I need to now subtract my triangle. So that's 1/2 base times height. Now, here's where those special right triangles come in. Because I have to think about here, if I were to divide this, I need to know base and height. So this would be the altitude of that isosceles triangle. If I do that, I've now created this 30, 60, 90. Okay, so I'm going to blow it up over here. Okay, we know this is 60. We know this is 30. We know our radius is 24. So that radius there is the hypotenuse. I need to divide by 2 to get my short leg. My long leg then is going to be 12 radical 3. Now keep in mind, this part is 12 radical 3, and this side over here is 12 radical 3. So when I go to do my base and height, my base really goes this whole distance. So my base is going to be 24 radical 3 times the height of my triangle is this piece right here. So that's 12. So let's go ahead and try to clean this up a little bit and simplify some things. So area equals, I'm going to have 1/3 times 24 squared is 576 pi minus, let's see, half of 24 is 12, and 12 times 12 is 144 radical 3. So the nice thing is 576 is divisible by 3, so that simplifies to 192 pi minus 144 radical 3. And again, we can leave it as square units. That's as simplified as it can be. You're also welcome to type that into your calculator. So if I were to type that in, make sure you're using parentheses if you need to. When you type that in, you should have 353.8 square units.